Hey guys, hope everyone had a good week. Um, Had a nice weekend. The weather was great. Hope you're finding a way to get out and enjoy the nice weather when you can. Um, you know, just wanted to say super proud of you guys. The people that are turning in their work are just doing an amazing job. And man, I really miss being in the classroom. I think this has just been incredibly tough that I don't get to conversate with you guys and laugh and joke around and stuff like that. But we're doing a great job with this. We're going to get through it. Everything's going to be great. I'm looking into teams to try and schedule times when we will get together as a class, and that way I can kind of teach you guys kind of like how it would be like right there in front of you, and go over stuff. So I'm going to be looking into that, and when you guys get back from spring break, um, we will hopefully have something set up to where we can use that to to go over lessons and stuff. Okay. So today we're looking at ellipses. Okay, we're looking at ellipses. Okay, and so ellipse is like a kind of like a football shape. It's like a flattened. It's kind of like taking a circle and like on the sides. It's like or like when your grandmother like pinches your cheeks or wherever and like pulls them out or whatever. I don't know if that still happens. That used to happen all the time when I was younger, but I don't know if that is custom anymore. But or think of like Hey Arnold football head. That's kind of what like an ellipse looks like. Okay. So I'm going to go ahead here and I'm going to draw two axes so you can guys kind of see what it looks like. Okay. And then we're going to go over our values here, kind of look at our formulas, that type of thing. And then we'll go over these two questions and then I will be available tomorrow to answer any questions. Okay. So our center again, h comma k. Okay, that's always going to be the same for all these shapes. Our center is h. Okay, all right. Our vertices, okay. And let's see, before I do the vertices, let's go ahead and just write that. The center is the intersection of the major and minor axis. Okay, so the major and minor axis, and we just say h comma k. Okay. Your vertices, okay, your vertices are the endpoints of major axis, of the major axis. Okay. We say this about A, A equals, okay, distance from center to each vertex. Okay, so A is equal to the distance from the center to each vertex. Okay. Our covertices are endpoints of the minor axis. Okay, so that's where B comes from. B is equal. Okay, so B is equal to the distance from the center to each co-vertex. Okay. So let's go ahead and let's kind of label those. Okay. So let's say this. Let's say this and this. Right here are our vertexes. So then this from here to here is what we would call A. That is our distance. Our distance from the center to the vertex is what we would call A. Okay. Let's go right here. Okay, our co-vertex. Okay, so from here to there is what you would call your distance would be B. Okay, and so guys, what's going to happen is that A is always going to be on your major axis. So right now what you're looking at after I draw this here is what we're going to have is a horizontal ellipse. You can have vertical as well, and we'll talk about that, how that occurs here in a second. Okay, but for now let's just continue on with the characteristics, because yes, this is brand new. You guys have never seen anything like this. Let's talk about foci. Okay, foci. Okay, so what we call foci is foci are fixed points on the major axis. Okay, they're fixed points on the major axis between center the center and vertex. Okay, so what that means is this then. So like we'll put an X here. Okay, for the foci, which foci is plural for focus. Okay, I know we had a focus with parabolas. We only had one, so we just call it the focus. But in this case, since we actually have two now, we call it foci. So the distance from here to there is what we would call C. Okay, that's our focus right here. This is our focus. Or we'll call it, actually we'll call it foci, sorry. Okay. And then, so how do we find C? C equals the distance from center to foci. Okay. C is equal to the distance from center to foci. Okay. All right. Let's go ahead here and talk about eccentricity. Okay, so eccentricity is a measure of how much the ellipse deviates from being circular Okay, so a measure of how much the ellipse deviates from being circular. Okay, so when the E is closer to 0, we get a big circular shape. When E is closer to 1, that's how you get your ellipse shape. Okay, so When your eccentricity is closer to 0, it's going to look circular, okay? We didn't have any focus. Our eccentricity was always 0. That's why it was with circles. That's why we didn't have to find it, because it was always 0. It was pointless, okay? All right, so how you're going to graph this, guys, is just kind of the same thing here. So you're going to have, so we're going to have, this is a horizontal ellipse. Why? Because my vertices are on my horizontal axis here, my x-axis, okay? And then my co-vertices are on my y-axis. Remember, your focus is always in between each vertices, all right? And so all you would do is that once you graph your vertices and your co-vertices, you're just going to connect them. Again, it looks like we took our circle and we just smushed it. Okay, and so it would look something like that. Okay, one thing to add is that our major axis here equals 2a. Okay, and then our minor axis, which always, and guys, here's how you know your major. Your major axis is always the axis with the vertices and the foci on them. Okay, your minor axis is always your co-vertices. Okay, your minor axis is always your co-vertices. All right. So how do we know when we have a horizontal major axis? Okay. Well, look right here. Here is our function. Okay. This is, I know this is new. Okay. So this may take a little bit of understanding to get to again. All right. But we've got x minus h to the second power over a squared plus y minus k to the second power over b squared equals 1, where a is greater than b. Okay. So the big thing you need to understand is look where this a squared is at. This a squared is under the x. When a is under the x, and how do we know it's a? Well, whatever the bigger value is, a squared is always going to be greater than b squared. Okay, so a squared is always greater than b squared. That's how we know that's the a squared value, or what a squared is equal to. All right, a squared is under the x. That's how it's horizontal. Okay, how do we know it's vertical? Look what happens here now. We switched. Now the a squared is under the y. Okay, therefore now it is vertical. So you would just take this and you would switch. You would have now vertices on the y-axis, foci on the y-axis, and then your horizontal axis would be your co-vertices. Okay, so that's the difference there. Again, a squared is always greater than b squared. A is going to be greater than b. All right. So again, we've got a bunch of formulas here. Okay. Again, it's just going to take practice. Take practice getting used to doing these. All right, guys. Okay. Once I go over these, you're just going to definitely have to practice these and then ask me a lot of questions if you're having a tough time. Okay. So again, let's kind of run down these real quick. All right. Our centers at h comma k. All right. Our vertices, remember, it's the distance from the center to a. All right. Our co-vertices is the distance from the center to b. All right. Our foci are the distance from the center to c, and we'll find all these first. We have to find a, b, and c. That's my first step. My eccentricity is c over a. And how do I find c? Here's the formula. It's c squared equals a squared minus b squared. Okay? All right. So yes, that was a lot to write down. Okay, just bear with me. We're going to go over both of these problems together. Okay, and then I will be available for questions tomorrow. All right. All right, so let's scroll up here. Let's keep, yeah, we should be able to keep our formulas here. Very good. Okay, so I'm going to go ahead first, create my x and y axes on both of these charts, graphs here. Okay, so there's my axes right there. All right, and now let's go ahead here and let's figure out our first couple of things we can do. First off, we can always determine our center. Okay, we can always know our center. Remember, same thing is applied. We've seen this with circles and parabolas. The h is always with the x, the k is always with the y. Okay, so do not get mixed up there. Do not get mixed up there. Right. So in this case here, our center opposite h and k, our center is going to be 3, 1. Okay, Next thing we need to find then is A, B, and C. All right. So now how do I determine? Well, A squared is always the bigger value. B squared is always the smaller value based on our characteristics right here. Remember, A is greater than B. Okay. So then we know then that this is A squared right here. So I'm going to say A squared equals 4. Okay. But guys, if you notice in the formulas here, I need A, B, and C. I need A, B, and C. Right? So what that means is that how do you get from A squared to A? Well, you're just going to go ahead and you're going to square root both sides. Square root both sides, and so you would get A then is equal to 2. Okay? I'm going to do the same thing. That means if A squared is 4, that means B squared then has to equal 1. Well, again, I need B, not B squared, to help me figure out my characteristics here. All right? And so when you square root both sides, B squared, square root of 1, you end up getting that B equals 1. Now, to find out C, okay, we're going to have to use our formula here, C squared equals A squared minus B squared. So I'm going to go C squared equals, okay, originally what was A squared and B squared equal to? So we're going to do 4, because that was A squared, right? Originally it was 4, minus B squared, which was 1. Okay? And so that gives me this now. That gives me C squared equals 3, which then, how do we find C? Square root both sides, and so you get that C is equal to the square root of 3. Okay? So once we find A, B, and C, now we can go ahead and we can figure out our vertices, our covertices, our foci, and our eccentricity. Okay? So let's follow our rules here, right? First off, how do we know this is a horizontal ellipse? What is A squared under? A squared is under the x here. A squared is under the x, therefore we know this is a horizontal ellipse. So I'm going to go ahead and I'm going to follow my formulas and I'm going to write them exactly like that. I'm going to write them exactly like that, guys. You do not have to go ahead and you can write them exactly as they're written right here. This is how I prefer it. It's a lot easier to grade that way when we have assessments coming up. So vertices, okay, H plus or minus A, comma K. All right, well, what was H? Remember, this is H, Y is K, right? So we would write our vertices like this. We would get 3 plus or minus, what was our A value? 2, comma K, which is 1. Okay? So if you were to figure out kind of what both your points were, and sorry, I don't have a ton of space here, you would just do 3 plus 2. So 3 plus 2, it's 5, comma 1. And 3 minus 2, which is 1, comma 1. So that's where both of our vertices should be. Okay? But I'm fine with you guys leaving it like this. If you want to leave it exactly like that when I check it come this weekend, I'm totally okay with that. Okay, totally okay with that. All right. Covertices. Okay. Covertices, look at our formula now. Okay, so now covertices, we're looking at the y-axis. That's why we're dealing with K. Okay, and we're moving up and down on that y-axis. Okay, our vertical axis there. All right. So we would write it like this. We would do our H value, which is 3, comma, K, which is 1, plus or minus what we find B to be? 1. Okay, and if you were to actually write out what those 2 points are, it would be 3, and then what's 1 plus 1? 2. And then it would be, what is, you would write 3 again, because you're not messing with the H value. And then what is 1 minus 1? 0. And so then both of our covertices should be at 3, comma 2, and then 3, comma 0. Okay? Foci, look at our formula there for foci. Our formula for the foci is H plus or minus C, comma K. So same thing again. What's my H value? 3 plus or minus. What do we find for C there? Square root of 3. Okay, and then K value is not touched, so plus 1. All right. So the foci gets a little bit difficult at times because you do have not a nice value here. So you would have to take your then calculator, guys, and on it you would just clear everything. This is algebra 2, sorry, clear this, clear. You would just do square root of 3 and then approximate it. So let's just round to the 10th, so we would say 1.7. Okay? So you would just approximate it and you would add and subtract from 3, 1.7. So 3 plus 1.7 is going to give me 4.7, comma 1. And 3 minus 1.7. Okay, so like even if I think about that in my head, what is 3 minus 1.7? 1.3, so you get 1.3, comma 1. Okay, so sorry guys, that's tough to see, but that's 1.3, comma 1 right there. Okay, my eccentricity, I do not want any decimals, just keep it in fraction form. So eccentricity is C over A. Okay, so it's going to be root 3 over A, which is 2. And that's how you would just leave it. Okay? And I guarantee you that eccentricity is between 0 and 1. Because if it was 1, it would be automatically be a really defined ellipse. If it was 0, it would be a circle. So if we go and we check what that value is, you would just do square root of 3 over 2. You approximate that, guarantee it's between 0 and 1, and it is. So it's 0.86. So when we look at this picture, it's going to look a lot more like an ellipse than it is a circle because it is so close to 1. Okay? So let's go ahead and let's graph our center here. So 3, 1. So 3, 1. Okay? And I'm going to label that with a C for my center. Okay? Now, how do I get my vertices? Well, all we do is what was our vertices? What was the definition for that? Okay, it's the endpoints of our major axis. It's A. A is the distance from the center to each vertex. Okay? Since A squared is under X this time, all we're doing is from the center is we're taking our A value, and so I'm going to go to the right, 1, 2. Label that with a V, and then I'm going to go to the left, 1, 2. Okay, they are equidistant, guys. They are equidistant. Okay? And when you check these 2 points here, what is this point? This looks like 5, 1. Was that one of our points we had up here? Yes, it is. This is 1, 1. Yes, it is. So we did everything correctly. We followed our formula good. We got our vertices. Again, since this is a horizontal ellipse, our vertices are going to be to the left and the right of the center. Okay? Co-vertices, all right? B is smaller than A, okay? So our co-vertices distance to go from the center to the co-vertices is not going to be as long as our distance to go from the center to the vertices, all right? So to find that, we know then since our major axis is horizontal this time, our minor axis is going to be vertical, and on our minor axis is just our co-vertices. So how do we find that? We just are taking our center and we're going up and down B because B is the distance from the center to the co-vertices. All right, so I'm going to go up 1. I know it's tough to see there, sorry. And write CV there, that's co-vertices, and then from the center I'm going to go down 1. So how did I get the co-vertices again? I went from the center, I went up 1, down 1, because that's what we found B to be. That's what we found B to be. Okay. All right, last but not least, okay, we need to put our foci in, okay. Our foci is the distance from the center. So C is equal to the distance from the center to the foci, right? And with an ellipse, guys, the foci are always inside the vertices. They're always inside the vertices. If for some reason you're graphing an ellipse, and your foci are outside of the vertices, you've done something wrong. When we get to hyperbolas, we will talk about actually that the foci are outside of the vertices. But for ellipse right now, they're on the inside, okay? So what do we find C to be? We found C to be the square root of 3, which is approximated to be 1.7, okay? So I'm doing the same thing I did with the vertices. I'm just going left and right, C from the center. Okay, so I'm just going 1.7 and I'm putting an X there next to it. Okay, and I'll label an F here for you guys. I know it's really compact there, so I'm labeling X there. I went over 1.7 and I'm going to go left 1.7 as well. And again, I know it's really hard to see. But guys, look at these X's there, which are your foci, are inside the vertices. Again, look how close they are to the vertices as well. The closer the foci are to the vertices, the more elliptical the shape's going to be. So now that we have everything graphed, all we're going to do is we're just going to connect our co-vertices to our vertices. And there you go. So yes, that's a lot. Okay, you probably might have to run the video over a couple of times just to kind of get down what I'm saying. Okay? All right, let's move on to the second one here. Okay? All right, and then you guys will be working on the 4 problems on the back. Okay, that is your homework. Okay, which will be due Friday night, right, by midnight. Okay, so here we go. So center, right? So my center here, okay, for this time here, I've just got x squared. I've got no value being added or subtracted next to it, so therefore h is just 0. Okay, I've got y plus 2, opposite, so negative 2 is k. So h is 0, k is equal to a negative 2. Okay, next thing now we need to find a, b, and c. Okay, so a squared, all right? So remember, a squared is always greater than b squared. So in this case, how do I know what a squared is? Well, what's the bigger number, 9 or 25? 25, okay? So we're going to say a squared equals 25, which therefore, after you square root both sides, you're going to get a equals 5. Okay? So then if a squared is 25, that means b squared then has to be 9. Again, guys, how do I know 25 is equal to a squared? The bigger value is always a squared. The bigger value is always a squared. Okay? This time I see b squared equals 9. That means when I square root both sides, I end up with b equals 3. Okay, and then how do we find c squared again? Look at our formula here. C squared is equal to a squared minus b squared. So we're going to say c squared equals, okay, what was originally a squared? 25 before I square rooted it. What was originally b squared before I square rooted it? It was 9. So 25 minus 9, that's going to tell me this. That's going to give me now c squared equals 16. Square root both sides, and you get now c equals 4. Okay, c equals 4. All right, now, what do we have here? What type of ellipse? Horizontal or vertical? What is the bigger number under? The bigger number is under y. Therefore, this is now going to be a vertical ellipse. Okay, this is a vertical ellipse because the bigger number is under the y value. Okay, so now look at these formulas when you have a vertical major axis. Okay, so the only thing that's happening now, guys, is that if you take your horizontal one, now you would change it. Your vertices are going to be here, your foci are going to be here, and now your co-vertices are going to be horizontal. Okay, so let's use our formula then to find our vertices. It's h comma k plus or minus a. H comma k, so what do we get for h? We got h 0, k negative 2, plus or minus, what do we get for a? 5. And if you wanted to write out the exact 2 points, you're welcome to. I prefer you just to leave it like this. Okay, you're going to get 0, negative 2 plus 5, that's going to give you a positive 3. And then you're going to get 0, negative 2 minus 5, negative 7. So you got 0, comma 3, 0, comma negative 7. Okay. Our co-vertices this time, what's our formula for our co-vertices? It's h plus or minus b, comma a, comma k. So h in this case is 0, plus or minus. What do we get for b? We got 3, comma k, which was negative 2. If you wanted to come up with the exact 2 points to make it easier for you to graph, you would just do 0 plus 3, which is 3. And then you don't mess with the k, so 3, negative 2. And then you would do 0 minus 3, so negative 3 minus 2. Okay. Our foci this time, we lucked out. Our c value is really nice this time, so our foci, what's our formula? Remember, our foci is on the same axis as the vertices. Okay. And so our formula then for our foci in this case is h comma k plus or minus c. So what's h again? 0. Comma negative 2 plus or minus, what'd you get for c? You got 4. So then if you're writing out your 2 points, you would leave 0 it is. What's negative 2 plus 4? Negative 2 plus 4, positive 2. Sorry, I apologize. This next point is going to be tight here. So then you would do 0 again. And this time you would do negative 2 minus 4, which is negative 6. Okay. Our eccentricity, guys, is just c over a, so it's 4 over 5, which is equal to the same thing as 0.8. I don't want decimals. I'm just showing that to you so that you guys understand, again, that an ellipse always has an eccentricity between 0 and 1. Okay, between 0 and 1. The closer it is to 1, the more elliptical the shape. Okay. Again, draw your x and y axis. Okay. Alright, so the first thing I want to do is I want to graph the center, so 0, negative 2. Okay. And we'll put a C there, C for center. I want to go ahead, guys, I want you to label. It's easier for me to check it that way, give back feedback. Okay. Alright, let's go ahead and let's label our vertices. So we know we have a vertical major axis. So this time from the center, I'm going to go up and down 80 at my vertices. So what did we find? A was 5, right? So in the center here, I'm going to go up 1, 2, 3, 4, 5. Put a V there. From the center, I'm going to go down 1, 2, 3, 4, 5. Put a V there for vertices. Which again, that should match what I have over here. So it looks like 0, 3. Yep. Down 1, 2, 3, 4, 5, 6, 7. 0, negative 7. Yep. Perfect. So we know we're graphing it correctly. Okay. My co-vertices, since this is a vertical ellipse, my co-vertices are going to be to the left and the right of the center. That's our minor axis is now going to be horizontal since our major axis is vertical. We're just switching it up from the first one there. Okay, so from the center, I'm going to go left and right, whatever B is equal to. We found B to be equal to 3, so 1, 2, 3. Put a CV there for co-vertices left, 1, 2, 3. Okay, which if we check those points again, and I know I forgot to do this on the first example, that looks like what? 1, 2, 3, down 1, 2. So 3 comma negative 2, yep. This looks like left 3 down 2, yep. Negative 3 comma negative 2. Good, great. We know we're doing this correctly. Formula's worked out. We calculated everything. Okay. Last but not least, let's graph our foci here. So our foci is always on the same axis as our vertices. So we're going to do the same thing that we did to get the vertices, except this time we're going from the center up and down C. Up and down C, okay? So what was C equal to? 4. So from the center, I'm going to go up 1, 2, 3, 4. Put an X there. And then below it, I'm going to label an F for the foci there. Okay, and then from the center, I'm going to go down 1, 2, 3, 4. X. And then label that with an F as well. So there's my foci again. What do we know about the foci? They're in between the center and the vertices. Again, inside of it. Your foci should never be outside. Your foci should never be outside. All right, so now once we've got all the characteristics labeled, we're just going to go ahead and we're going to connect our vertices to our co-vertices. And there you go. You get kind of like a football looking shape. It's like a kickoff, like how it's set up there, getting ready for a kickoff for all the sports fanatics. Um, all right, so guys, to recall, an ellipse has vertices, co-vertices, foci. Okay, determine where the a squared is. Determines to you whether it's horizontal and it's vertical. Okay, remember the major axis always has the vertices and the foci on it. The minor axis always has the co-vertices. Okay, co-vertices. All right. Your eccentricity should be between 0 and 1. You just find that by doing c over a. Okay. Yes, guys, and again, I know this was a lot. Okay. Just if you have to, just play the video over again, and then I will be available to answer questions tomorrow. Please be asking them on Remind or Google Classroom. I will upload the video to Google Classroom. The videos do not upload onto Remind, unfortunately. So, but yeah, guys, I just cannot tell you how much I miss being in the classroom with you guys, but I'm just so appreciative again to be your teacher. You guys have been doing such a great job with it, especially the ones that are turning in their work. Guys, if you're not turning in your work, please turn it in. We are going to start moving to putting grades in. Okay? You are going to be expected to do this stuff. And you guys are all definitely capable of doing it. I know that. You're all very bright. Okay? Guys, continue to just stay positive and find a way to, get past this time. But yeah, I miss you guys a lot, and I hope you guys have a great spring break. Okay? And I'll talk to you guys then after that. Hopefully we're in teams and we're all kind of talking and hanging out and laughing like we always usually do before class gets started. So, all right, guys. Talk to you in a couple weeks.